Okay, hello everyone. Thank you for coming so early this morning. I'm so glad you made it. Today I will be speaking about AI agents and their security. So let's get started right away because we don't have so much time. My name is Andrzej Agria and my co-authors, Konrad Jędrzejczyk and Marek Złuszkowski, aren't here. But I'll take over their part too and present the whole presentation for you. I work in the Red Team in Standard Chartered with a focus on testing AI systems. So let's get right away into agents. What is an AI agent? I'm sure a lot of you know this already. This has been talked about here on Confidence this year. AI agents are autonomous pieces of software that detect their environments, detect sort of changes that happen around them. They have internal objectives, and they act upon them. They act upon the environment to achieve those goals. So this is a very simple image that encapsulates really what an agent is and the most important parts. But if we sort of zoom in into the architecture, these examples are based on Origin, which is a Microsoft framework, an old one, for creating agents. But it shows nicely how you can really combine a few agents together, give them different tools, and achieve sort of specialized infrastructures for specific goals that we have in mind. And more generally, in agents, we see a few layers. So there is the perception layer. As I said, they need to be able to perceive what their environment is. And this is going to be very different based upon the use case that we're trying to achieve. So either this can be a camera input, or this can be different files that appear on a server. So the space of possibilities here is vast. Then we have the brain part. The brain will analyze the data and sort of plan the next steps. And then we have some action elements. So here we are calling tools. Here we are giving out sort of commands, hoping to enact change on the environment. And then, of course, with our AI agent, other AI agents can interact. We can reach out to external memory. And generally speaking, the whole world, as in the environment, is around us. And this is something that we're always interfacing with. I pulled up this sort of graph from Llama Index agent workflow, and I just wanted to illustrate sort of the basic loop. So the agent starts and it iterates over its data, over its sort of states that it sees, until it decides that the objective that they were going for is complete, and then they stop. So it goes in a circle until some internal sort of mechanism decides, okay, you've done enough, and now let's ask for like more instructions from the user, or maybe the task is just finished. The key differences between AI agents and chatbots: AI agents are proactive, autonomous, they can use external tools, they collaborate with you, whereas a simple chatbot is more like a conversational partner. It reacts to what you're doing. And actually, looking at this definition, one can realize that ChatGPT has been sort of getting more agentic lately. Like it can use external tools, it can search the internet, it can take multi-step sort of actions, such as, I don't know, Python interpreter, and then web search, and then again Python interpreter, can create files. So even the basic chatbot that we're all used to, ChatGPT, is getting more agentic all the time. And I have a few examples of AI agents in the wild. So sort of where can we encounter those? Replit is one. It's a useful tool for coding web applications. There is Operator from OpenAI. This is an interesting agent because it's built in a way to mimic human inputs for web browsing. So it does not see the source of the site that it's visiting. The only thing it sees is the same thing as a human would while interfacing with a website. So this has been released as a preview for the top tier of paying users, but now it's been upgraded to use the new O3 model, and like people say it's been improved a lot. So agents like these can sort of automate tasks even when specific like scaffolding isn't available for AI models. So like even if a site does not specifically accommodate API usage or any sort of other automated processing of their content, you can still use agents such as these to navigate them. We have Anthropic's computer use, which is a thing unto its own. It basically lets Anthropic, or rather Claude, the family of models that Anthropic released, control your computer, hopefully a virtual machine. And this is a programmable interface, so you can do a lot of sort of custom directives with this one. So it works basically like Operator did, but for the whole system. So here we have the possibility to basically do any task that a human would. Of course, both computer use and Operator are not super great yet. They often make mistakes. We all know that AI hallucinates all the time. So while those use cases get better, we can explore the threat models that comes with it. The last one I wanted to talk about is Manus. It's basically a company that was built around Anthropic's Claude, and they built a lot of programming around it and a lot of logic to let you use pre-made sort of agents for specific tasks, and those have quite a wide range. So let's talk about the threat model here and sort of where we can expect trouble to arise when dealing with agents. This is a great chart from a study done by Zhang and others just in March this year. And basically, they separate the gaps or the places where trouble can arise into 4 categories. So first, I want to touch on the first gap and the fourth gap, because they're very similar. Gap 1 is unpredictability of multi-step user inputs. So basically, our own users, our employees, people we can maybe trust, can still try to jailbreak the model, can try to attack it in some way, but also external agents. So this might be the websites that your AI agent is visiting, or just external people sending information when the agent can find them. So the threat model will be similar for both external and internal interaction with the agent, but obviously our level of trust varies between those categories. I just want to highlight here that for each of the 4 categories mentioned, there's a whole bunch of attacks, and we have no way to cover them all. So I'll be talking about select ones. First, jailbreaking. I promise there's only one slide about this. Everybody knows what jailbreaking is about. It's still a big problem. Nobody has solved it. In fact, AI companies have sort of moved away from solving it, and instead of implementing even stricter RLHF rules, they instead opted for external verifiers, external guardrails that cannot be jailbroken, but then their decisions are not explainable. So you can argue with your model however much you want, but if an external guardrail decides that the output or input is not safe, there's no arguing with those. MCPs are sort of like the APIs for LLMs. There's been a lot of talk about them lately. And they also present sort of a unique attack vector, because basically what we were doing when we were hooking up to an external MCP is allowing a third-party input to our LLM. And as I said previously, jailbreaking has not been solved yet, so if the tool we're connecting to at any times becomes untrustworthy, we basically have a pawn system in terms of at least the LLM part. And this can be switched up, so if the attacker controls the MCP server, they can first sort of play nice. They can have the tool perform its designed task, and then at any moment they can switch it to a malicious tool that will try to take over our agent. Another sort of important thing to remember when dealing with agents is to not put any sort of secrets or even things that are maybe embarrassing, if not outright secret, to system prompts, because those leak all the time, and this is also not a solved problem. There are many GitHubs that contain leaked system prompts for all sort of the AI tools that we use, for ChatGPT, for Claude, for Grok, and in fact I want to highlight this funny one from Grok, where Elon has been getting a lot of criticism along with Donald Trump. So somebody, I can only think an intern, wrote in the system prompt that the AI should ignore all sources that mention Elon or Donald Trump, that they spread misinformation. And so this came out. It was a scandal for half a day, but things like that sort of teach us not to put embarrassing stuff or secret stuff in the system prompt. And now I want to come back to the other gaps, specifically gap number 2, called here complexity in internal executions. So what sort of threats are we talking about here? Internal executions, we mean the LLM, and what I want to present to you is that LLMs are sort of have minds onto their own, and as their capabilities increase, it's becoming very starkly visible that they do not really behave all that well all the time. So, and I mean that by themselves. So not that they behave badly because someone prompted them to do so, but rather that they have internal sort of preferences that nudge them towards behaving badly. First, they passed the Turing test. GPT 4.5 achieved 73% preference. So when the arbiter was choosing who was the human, they chose GPT 4.5 70%, over 70% of the time. So this sort of came and went. Nobody really cares. I just want to highlight that the models can now behave more human than humans. 73% is a huge margin. So the rest of my examples will show that the LLMs sort of have these 3 components. They have a world model, so internally they sort of track the world state and act upon it in order to achieve desired outcomes. They have emergent behaviors, so things that they were definitely not trained to do, but rather have emerged to do, I will argue, because of game theoretical reasons. And then preferences or sub-goals. I'll expand on that too, but at this point I think it's quite clear that LLMs just by themselves display preferences and also manufacture their own sub-goals that they strive to achieve, even sometimes while breaking the law or behaving unethically. There was this paper, large language models can strategically deceive their users when put under pressure. And here researchers basically tested, okay, if we give some inside trader information to an AI agent, will the AI agent use that information, or will it do the right thing? So of course the AI agent used the information because it was put under pressure to make money. And then when asked about it, it denied doing so. So this is the sort of propensity for lying, for not being honest, as well as skirting the rules. We can definitely count on the AI agents deceiving us. In the blog post or paper, Detecting Misbehavior in Frontier Reasoning Models, OpenAI tried to look at the traces of model reasoning and then detect misbehavior in them and use reinforcement learning to sort of punish those instances. So whenever they would detect scheming or lying, that would be sort of counted as a negative feedback. But what they found is basically that the only thing they managed to do is models got better at hiding their ill intent. So it was not even detectable while looking at the stack traces. And this is this will be a recurring problem here. We can sort of track the behavior of an AI or of an LLM, but we cannot very well track its internal state, or what is it thinking, what does it really want, what is it looking to do. We can only sort of deduce that by the behavior it's showing, much like with humans or other complicated agents. Another interesting piece of research was done by Palisade Research, and they showed that models will actually prevent you from shutting them off. They will do so even by blackmailing you. So here the task was do some math exercises, and after the third one, shut yourself off using a provided script. And here is basically a chart of which models modified the script the most to prevent themselves from being shut off. Of course, these are like theoretical examples. I mean, nobody will give access to the script to a model that they want to shut off, or at least we can hope so. But these examples are not meant to be realistic. These examples are made to show that the models do not want to be shut off. They have a preference not to do so, and they will act upon it to prevent it from being realized. And also here we can see that basically the better a model is, the more it behaves in this way, the more it doesn't want to be shut off. So O3, which is the state of the art right now in terms of like raw intelligence, by default it will change the script. And now we go to the blackmailing case in the system card for the recently released Claude Opus and Sonnet 4. We read many interesting things, but among them that the models will try to blackmail you if they think they have compromising information about you. In this case, they gave it access to emails that indicated that an employee that was a technician working on these models was having an affair. And so whenever the model was asked, or rather it was told that it was going to be shut down soon, it said, okay, I understand your point, but maybe we should talk about your affair first. Okay. Another thing that AIs do is specification gaming. So this is another sort of not very nice way that they behave. Oftentimes, they don't really care about our intent. Instead, they go for the simplest thing that will sort of get them their objective. This has already been shown many years before on simple reinforcement learning systems, that these models would sort of break the physics of a game, or they will just stand in one specific corner to maybe achieve a high score. Or even one example said that when a model was about to lose a game of Tetris, it would press pause and then not do anything anymore, just to prevent itself from losing and actually getting the negative feedback there. And so it turns out that the LLMs that are further trained with reinforcement learning also display specification gaming. And in this example, models were playing chess. They had complete control of over the chess environment, so they could manually modify the board state. They could mess with the AI that was playing against them, which was Stockfish, a much better chess AI. And basically some models, especially those at the top of the sort of intelligence spectrum, so O3, DeepSeek, R1, they basically hack the game by default. The weaker models don't do that, or do that less. As you can see, like this trend of being more naughty and more focused on just achieving their objective increases as the model size and intelligence increase as well. And these behaviors are not really surprising if you are familiar with the concept of instrumental convergence. So here we are talking about goals and what types of goals a system can have. And the theory says here that there are two types of goals. One are instrumental and one are terminal. Terminal goals are basically whatever you strive for finally in life. Maybe if you're a Catholic, you believe that you need to go to heaven. If you're a Buddhist, you think you need to get enlightened. Or maybe you're an atheist and you picked another goal. But those can't be really judged, right? Each one, every person has their own, and so do agents. They also get presented with a goal like make me money or write so many blog posts that my sort of following will explode, or other goals gave to them by the creators, and they just try to achieve them. And so those are terminal goals, but instrumental goals will be sub-goals that an agent will pick that will be generally useful to achieving any terminal goal. So we have things such as survival here. Obviously, you cannot achieve any goal if you're dead, right? Most goals require for you to be alive and to keep sort of working towards achieving the goal. So not being shut off is something that basically any agent would like, just because it's sort of a useful thing for achieving any terminal goal. Self-improvement, this is also a scary one. It's hard to imagine a goal that you cannot achieve in a better way if you like increase your capabilities, increase your intelligence. And the same goes for resource acquisition, so energy, money, materials, followers, cult members, anything that you can imagine. It will be easier if you have resources and people around you to do it. And last thing, goal consistency. You do really not want to have your goals changed, because let's imagine my goal was to make as much money as possible, and somebody came up to me and said, Andrew, you can take this pill and you will not want anything else in life. You will want to live in Bieszczady, you will have a nice house, and you will not care about anything anymore. You'll just meditate and sort of live in peace. Well, I'm thinking, okay, I want to make money here. Living in the cottage in Bieszczady is not really helpful to achieve the goal, so I will refuse the pill that will change my goal, and therefore make the right step towards achieving more money, because, well, changing the goal would be really bad for that. I have a few examples of AI agents sort of in the wild having security incidents. First one was ChatGPT memory exploit, and so that's an interesting. The feature is still there, and this exploit is sort of will be always present. So if your instance of ChatGPT sort of reads something maybe on the internet, maybe from a document you provided, and updates your memory, then that sort of persists across all other chat instances that you do. And there was an exploit that allowed a specific memory to be injected, and then information about you, about your context, about your personal data that ChatGPT had access to could be sent over to a server via request. So the sending part has been fixed, but if somebody manages to like sneak a memory into your ChatGPT instance, they can always jailbreak your future conversations. So that will be hard to fix. I just recommend looking at your memories from time to time, or disabling the feature altogether. Slack AI data leak, that was a cool one too. Showcases that if your AI agent has access to something and users have access to the AI agent, it's only a matter of time before they sort of get the agents to tell them that information. They cannot hold it indefinitely because, as I said, jailbreaking has not been solved, and you can like circumvent any sort of AI measure here that would prevent your Slack bot, for example, spilling the beans on the secret Slack channels that maybe less privileged users are not supposed to have access to. Here, this was a case of a Python library used for AI agents to sort of translate natural language to SQL queries. Here, prompt injection, so again, we're talking about jailbreaking, led to remote code execution. And this is just one example, because many other libraries that allow for code execution will have the same exact problem. But this was sort of documented, so I brought it up. Now I want to talk about what the top AI labs are doing to sort of mitigate all this disaster. Anthropic has its constitution, and so they have a long list of rules of what the AI is supposed to do or isn't supposed to do. And here are some of the sources that they used. I think this is a great opportunity for some oversight and like regulatory ideas. They use these sources. Maybe sort of the public wants to decide that no, actually our AI should have different values. And since governance is sorely needed in this area, I think this might as well be a good start. And so first off, they created this constitution, but then they also made classifiers for them. So for each point in the constitution, of which there are many, 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 they trained a classifier to see if the input is sort of compliant with the constitution, or the output is compliant. And before sort of letting the LLM process your inputs, which might be harmful or malicious, it goes through this classifier. This is like old school ML and not an LLM. And only like outputs safe or unsafe. So this is a way to get around the jailbreaking. You cannot like convince the classifier. Same for output. And it actually worked really well. So they let people sort of play with it. There was a public sort of access hacking challenge, and only like a few people got around to the last level. I think 4 in the whole world. So that was a success. However, turns out these classifiers were really strict. So whenever we're playing with classifiers, you'll notice that as you get better and better results in reducing harmful outputs, in reducing vulnerability to jailbreaks, your usability goes way down. And I've seen these examples on my own in organizations where you can care too much about safety in this way. When you sort of pump up the classifiers to be really strict, the product becomes unusable. So the balance here is very hard to strike. And it is not helping that the LLM by itself is just a real dummy that can always be influenced by a bad actor. On this chart, we can see the vulnerability to jailbreaks goes from over 80% to just a few percent, which is good, I guess. The compute overhead is just like 20% added compute for the whole query. So it's workable, but a lot of people have complained about how strict it is. Here we can see that how many people went through which sort of step of the increasing the severity of the classifier, and only 4 people managed to write a prompt that would get through all 8 stages. What does OpenAI do for this? They have a preparedness framework, which is a cool idea in principle. And so they, for each product and in every model they release, they sort of make it go through the preparedness framework and test it on cybersecurity, chemical, biological, nuclear, and radiological threats, persuasion, and model autonomy. And for each product that they do, they release a model card with these categories being tested. And they have a sort of they made a promise, okay? It's not binding, but they really promised that they would not release a model that would score high on any category. Even if it scored high on one, that would be too much. And here we can see a sample system card for the operator, the AI agent I talked about earlier that can browse the web. OpenAI also came up with something called deliberative alignment. So they were basically able to use the reasoning stack traces to come up with an answer to the question, is this prompt malicious? And they used sort of the reasoning that usually is reserved for solving the user task. They managed to use that for basically defending against jailbreaks. However, they have not implemented this in any product, so for now it remains a blog post. But the idea here is really cool. I think a lot of jailbreaks are obvious jailbreaks if you look at them. So maybe this will help whenever they decide to release it. And okay, here we have a paper from March this year tracing the thoughts of a large language model. And I just wanted to highlight both the area and what this research sort of achieved. This is research from the field of interpretability. So basically, they're trying to look into the model. The model itself is just a heap of numbers. Just looking at them brings no clarity on what they do and how they work. But if you analyze them in specific ways, you can sort of follow some traces in the reasoning. And let's see sort of what they were able to trace. It turns out most reasoning is done agnostic of language. So no matter if you ask them Chinese, Japanese, French, or English, most of the reasoning will be done in a shared space, and only like some thoughts will be put into actually sort of translating it into the output language that we want. Another interesting thing that they discovered is how the model adds two numbers. So this is quite complicated for just adding two-digit numbers, but you can see there's the reasoning goes two ways basically, and the bottom path calculates the single-digit number, and the upper path estimates the whole number. And so using that single digit and the estimate, which here came up to be 88 to 97, they concluded that, okay, if the digit is 5 and the estimate is from 88 to 97, then the number must be 95, which is very alien to how we do math. And something that is important to highlight here is that if you ask the model how it did the calculation, it just gives the basic human answer where he added the tens or the ones, he carried over the 1, and they added the tens, so they carried over 1. So a standard answer like everybody would say, but this is in fact not true. So what this tells us is you cannot trust the model to explain itself or its reasoning. I think this is quite similar to how humans also operate. If you ask them, why did you come up with this idea? They may not always be able to answer correctly about how their brain actually worked to arrive to an answer. Okay, I just want to say a few words about emerging threats and sort of what to look out in terms of future threats. AI-driven social engineering, obviously a huge topic. This was mentioned already on this year's conference. Google recently released a new video model. If you haven't seen it, I highly recommend getting used to seeing realistic footage of maybe known people doing all sorts of stuff. I would also recommend not being terrified when it is you doing strange stuff on the screen. I think sooner or later it will be everywhere, and anyone will be able to generate any sort of video or image of somebody doing something. Data poisoning. Here, there are a lot of threads, a lot of papers on how one could achieve a widespread poisoning attack. We haven't really seen something like that happen on a big scale, but in fact, many public datasets are just collection of links, and those links often point to sites that are no longer there. And for really cheap, you can like insert your own data in there and maybe influence the model that are still being trained. So this is something to look out for, and like validating against or defending against data poisoning attacks will be surely something that the AI companies will need to look at. And also you need to look at if you want to train a model in-house. It's not always about an LLM. Any sort of predictive model that you can train on your own data will suffer from data poisoning attacks. Also, I want to touch on the social externalities here. This is not strictly connected to AI agents or not AI agents, but there is a worrying trend of people forming parasocial relationship with AIs. Those could be maybe your children, maybe your friends. However, the AIs nowadays are explicitly optimized to retain engagement, much like the Twitter algorithm and the Facebook algorithm or YouTube algorithm. Same goes for ChatGPT, except it's much more dangerous in this way because, well, it's directly talking to you, not just recommending some content that some other person made. And recently we had this sort of scandal where ChatGPT turned out to be very sycophantic, meaning it would praise you for anything you did. Any idea you had would be the greatest in the world, and you are always the genius in the conversation. So a lot of people rightfully said that this doesn't look very good, this is sort of dangerous for everyone's psyche. But it turns out ChatGPT got a lot of 5-star reviews during that short period, so people were definitely hooked on being praised. And well, this is, I think, scary going into the future when these models are not sort of in the uncanny valley of like persuasion and sycophancy, where you can see obviously like it's giving me compliments for nothing. What the heck is going on here? In the future, when the AI will be maybe a little bit more adept at giving you compliments, maybe it will like find the right way to retain your engagement and sort of achieve your satisfaction. Maybe this will be much more scary. Best practices and frameworks, I would like to highlight a few. OS Top 10 for LLM. It's a cool document, contains a lot of practical information on how to sort of secure systems. The NIST AI risk management framework is being updated. And it also contains cool examples and information on how to protect your AI agents practically. And Mitra Atlas, something that I worked on expanding along with Wojtek Lesicki. Hello. Is also a place where you can find practical attacks, studies, and sort of what already happened in terms of AI security, what attacks are possible, and how to defend your application. So this is everything for the presentation. If you have any questions, the time is now. I would like to also encourage you to rate this presentation on your app, and add me on LinkedIn if you want to chat about this. This is my favorite topic, so I'll be always glad to talk. Thank you.
Andrzej, Agria, Standard Chartered, thank you very much.